Hey folks, Doug Blake with Body Design University. Welcome to another Saturday live study. Today in this video, we'll be talking about bioenergetics, give a kind of a broad overview of the different energy systems and start that process. This is in module one. It's at the end of lesson two in module one. So ladies, it's good seeing y'all. Remember, if you got questions, just raise your hand. I'm going to go ahead and share my screen. Let me get this up here. And does everybody see my screen? Yes. And I'm going to go ahead and expand that for you guys. Are you ready? So, having finished up with the muscle groups and the kind of the biomechanics of human movement, now we move into kind of the last part, the really important component of exactly how do muscles or muscle cells get the quote energy they need to perform the functions that they function. And so what we do is we break down these energy systems inside the body. And you can break them down any number of ways, but the easiest way that I've always seen is kind of a standard explanation of the aerobic versus anaerobic systems, right? And so we start out with the fastest energy producing systems that we know in the body. And again, folks, remember, although this applies to other cells in the body, I'm not interested in talking about your pancreatic cells or your liver cells, right? We're trainers and we're talking about muscles, right? But this works and is understood even in all the other organelle cells of the body. And so in muscles, right, we have, right, the most fundamental energy unit, right, which is ATP. Raise your hand if you've ever heard of ATP. I know you have, right? Adenosine triphosphate. It is a what's known as a high energy molecule. Okay, it is the energy molecule of life on Earth. Pretty much every living system that we know have seen, looked at, use in some way, shape, or form the AT molecule to provide energy for living cellular systems. Does that make sense? So ATP, that's why we call it the fundamental energy unit at a cellular level. Okay, doesn't matter what you eat, doesn't matter what's going on in your endocrine system, doesn't matter what's going on anywhere else. At the end of the day, in the cell, right, muscle cells, for instance, um, cells are able to perform their many functions because we have what's known as ATP, and ATP has a very specific way in which it is able to provide energy. And so that's where this first heading title comes from, ATP and energy systems. So it's a fundamental energy unit. It is produced through, and this is why we break it down, it just makes life easier to explain it this way. We break down the production of ATP through two different, what we call metabolic pathways. Aerobic, what's aerobic? So with oxygen. So aerobic means with oxygen, or anaerobic, which means without oxygen. So aerobic, anaerobic. So aerobic, just like you did aerobic exercises, right? Remember that was like back in the day when we used to call exercises aerobics. I'm going to do some aerobic training. We don't say that, I hope, anymore today, right? We call it group fitness or cardio training, right? We don't use the term that we originally used, which was aerobic training. So aerobic with oxygen, anaerobic without oxygen, and your body can use different what we call substrates. That's simply the stuff that we get from our food in the form of glucose, right? Carbohydrates, free fatty acids, right? These are the breakdown components. So these are the basic components of the foods we eat. Glucose, you can get glucose from foods, obviously, straight from foods, but generally the glucose we get in our bodies from nutritional sources is going to be from carbohydrates in any form, generally. Okay. Free fatty acids come from what? Fats, right? Amino acids come from where? Proteins. And then what we have, what we call ketone bodies. Ketone bodies are simply a byproduct of the breakdown of fats. Okay. So ketone bodies come from a metabolic pathway that we see generally in the liver with the breakdown of fats. So those are your, now we could add alcohol. You guys know that, right? Alcohol actually can be used as a source of energy. The reason we don't include it is because we don't want people drinking alcohol to begin with, because it's just not good for you, period. So there's no benefit to the consumption of alcohol in your diet whatsoever. And therefore, we don't want people to think that that's an acceptable way to get calories in their diet. So we don't include that. It's a byproduct of yes, the reality that alcohol provides 7 kilocalories per gram. So, but we do not put that in as a normal part or normal list of substrates. Okay. So what we do first is we look at the anaerobic pathways. Next week we'll look at the aerobic pathways. So we have a number of ways in which the body can produce ATP. So everything I just spoke about, the whole point of everything we just talked about is to go from food you eat to ATP in a muscle cell. That's it. That's how this works. Irrespective of all the other metabolic activities occurring, when it comes to the development of energy for use in muscles, it goes from what we eat, how it's broken down digestively, and ultimately at the cellular level for the production of ATP. Now, um, we have a couple of different pathways. The first one is what we call the ATP-PC system of ATP production. You got it? ATP, and this is called phosphocretin or the phosphagen system. I know you're saying to yourself, why all these words? They all basically mean essentially the same thing. But the ATP PC or phosphagen system of ATP production is the fastest way that the body gets ATP into or within the functioning muscle cells. Is everybody with me on that? Give me a thumbs up if you're with me so far. Yes? So during the first few seconds of any muscular activity, anything you do, your body already has, i.e., muscle cells and other cells in your body, already have stored ATP. There's already the molecules ATP in your muscles. Not a lot, but there's enough to get things going if you need to move immediately. You know, get that? So there is some stored ATP, but again, not a lot. And it's within the muscle fibers. It supplies energy needed for these activities that need immediate energy production. It's a limited supply, so it gets used up very quickly. And I'll use an analogy. Let's just say we'll just focus on the biceps, right? Your muscles in your muscle fibers in your biceps. You pick up a dumbbell and you start to do a dumbbell curl, right? Within a split second, the ATP that is required to get those muscles to contract, that is generally for the first couple of seconds is going to come from the already stored ATP in the muscle. Simple, right? So you already have, it's like you get in your car. Do you have gas in your tank? I hope so. Right? You all got some gas in the tank, right? Well, think about it. You got your gas tank, but then you have what's known as a fuel line. Okay, well, I'm not going to get into automotive engineering with you, but I do want to give you a basic concept. So you have some fuel in your fuel line, don't you? I hope so. Way back when we used to use carburetors, right? Ainsley, you don't even know what a carburetor is because you're so young. Okay. We used to use carburetors, which would mix the fuel and the air to create ultimately the quote movement or explosion in the inside the engine itself, the engine block. So you already had fuel in there. I mean, there's a big container of gasoline in your gas tank, and that little bit of gasoline that's already in the fuel tank, that's the first stuff that's used immediately, right, to be pushed into this carburetor to start the engine going. That's the equivalent of the ATP-PC system in your body for ATP production. It's already there. There's already a little bit of gas in the line, so to speak. Does that make sense? Okay. And so it's very limited. It gets used up very rapidly, very quickly, within the first 3 to 5 seconds of any muscular contraction. That ATP is just there to start things off, right? So it's a limited storage of ATP. It gets used up. And then another molecule in the muscle known as creatine phosphate or phosphocreatine. So you could say ATP CP, but it's normally designated as PC, phosphocreatine, or creatine phosphate. Does everybody see that? By the way, what do you see here? What's that word that you see? Whoops. What's that word that you see right there? Creatine, right? So that should trigger something in you. What's one of the main supplements that we recommend people use? Creatine, right? Creatine monohydrate, whichever one you use. And the reason we recommend people use creatine, depending on what they're trying to accomplish, is because if you can get more creatine, right, into your muscle cells, you'll have a greater supply of this ultimately ATP producing or assisting part of the system. That's one of the reasons why we can use creatine. The other is that we simply volumize the muscle, but everybody sees that. So creatine phosphate. So the ATP and the creatine phosphate work together in tandem, right, to ensure that for the next, I don't know, 5, 6, 7, or 8 seconds, there's enough ATP to be produced. And the way this happens, I'm not going to get into it to any great extent. By the way, there's some great YouTube videos you can watch that will show you, like, pictures of how this functions. It's actually pretty cool. The ATP has three triphosphate. So it has three phosphate molecules connected to it. The terminal the terminal phosphate molecule, that third one in the line. So you have the adenosine molecule, phosphate, phosphate, phosphate. That terminal phosphate gets broken off. That's what provides energy. And now you have ADP, or adenosine diphosphate, and a free-floating phosphate group. Well, what happens is that the creatine phosphate, right? It's just a creatine molecule with another phosphate. It jumps over and adds that third one back to the ADP molecule. And guess what you got? You got ATP again. So you have an ATP molecule, gets rid of a phosphate, kaboom, energy to allow for muscle contractions. And then the creatine phosphate comes back over and says, you know what? Here, I know you don't want to be an ADP molecule anymore. You want to be an ATP molecule. Here, take my phosphate. And so creatine phosphate sacrifices itself, every molecule sacrifices itself to get the ATP molecule back with three phosphates. Okay? I tried to explain that slowly. But does everybody understand? ATP, boom, becomes ADP. Creatine phosphate comes back and makes it ATP again. It's just this cycle, back and forth, back and forth, back and forth. Got that? So ATP itself, there's enough ATP without the creatine phosphate to get your muscles working and active for, I don't know, 3 to 5 seconds or whatever. It depends, obviously depends on the individual. And then when that's used up, creatine phosphate essentially steps in to kind of buffer this and allow for the continuation of ATP by sacrificing itself. So the entire process provides, as you can see here, 15 seconds, upwards 12 to 15 seconds of activity. So think about this for a second. If you're doing a dumbbell, count from 1 to 15. You can understand why for the first part of your set, or you're running, or you're for the first 6 or 7 reps of like a dumbbell curl, you could, it's not this simple, but essentially that's being fueled by the stuff that's already in the muscle. Does that make sense? Okay. So of course that's going to be used up. And so after 10, 12, 15, maybe longer seconds of activity, before there's a necessary shift, as we say, now you got to get another energy system, because what happens when you run out of energy? You got to have another system to supply the ATP. Well, this is where that next system comes in, and it's called anaerobic glycolysis. Y'all got that? So system number 1, ATP-PC system, provides immediate ATP for working muscles for upwards of just use 15 seconds. It's just easier because that's what you'll probably see on a test. But it's normally anywhere between 10 to 15, roughly like that. It ain't 2 minutes. I'll give you that. How's that? Right? This is like real quick stuff. And then the body shifts into what's known as anaerobic glycolysis. And you can see after roughly 10 to 15 seconds, what happens? The ATP system essentially shuts down, especially if you're continuing to do work, right? Okay, the ATP-PC system gets regenerated once you stop the exercise. Let me say that again. That system, that short-acting system, regenerates, recovers almost immediately once you stop doing the exercise. So as soon as you put that dumbbell down and stand there, literally within 3 to 5 seconds, most of that ATP has been recovered. And now you can start again. You get it? So your body is very efficient, very effective at ensuring that muscular activity can continue and there's going to be recovery and recuperation of that particular system. So I hope that makes sense. But now we need another system to help us after that 15 seconds. And this is called the anaerobic glycolytic system. Y'all got that? See the word? Anaerobic. Okay. And again, we'll talk later about the aerobic glycolytic system. But right now we have the anaerobic glycolytic system. And it's really very simple. At this point, the glycolytic system, right, beginning with anaerobic glycolysis, begins the process of sequestering. That's a SAT word for those of you that took the SAT back in high school. Sequestering of ATP from glucose. Okay, guys, so this is where we step into what most people understand about bioenergetics, which is that when I eat food and it gets broken down, whatever it is, into glucose, glucose in the blood is able to be converted into ATP inside muscles. Y'all got that? Okay, and without getting too complicated, the ATP generated from glucose in the anaerobic glycolytic system provides ATP, right? But also produces a lot of byproduct. Y'all got that? So I can use glucose. Glucose is a energy molecule, right? That needs to be broken down, right, into ATP, and it does that through fairly basic pathway that you guys don't need to get into. But each molecule of glucose is broken down into two molecules of pyruvate. And you should know these terms. Pyruvate. Okay, so glucose gets broken down into two pyruvate molecules, and those pyruvate molecules, that's what ultimately allows for the production of ATP and then this byproduct known as lactic acid, which converts quickly into lactate. So you should know those sequences. So the pyruvate molecules, if there's no oxygen present, right, that's why it's anaerobic, they metabolize into lactate, which is then removed from the cell, from processing in the liver. Believe it or not, this byproduct of anaerobic glycolysis metabolism actually gets converted back into glucose in the liver. So your body can keep recycling this stuff. Okay. This is not we used to call these waste products. I remember when I learned this, when I learned everything we're talking about here, and we're talking, 1970s and 80s. When I learned about this, it was that you had a buildup of lactic acid. That's what gave you the pump and the burning sensation. Yeah, you all remember that? So you got lactic acid, and it's a waste product. We want to get rid of, man. We want to get that stuff out of the muscles, right? Well, yeah, no, not really, because it's not a waste product. The body doesn't generally waste things. There are waste products that the body wants to obviously get rid of, and that will happen generally through the kidneys and your sweat glands. But in this case, your body can actually take that lactic acid, and we used to say It was all lactic acid until we realized that actually it's not lactic acid. Lactic acid gets converted into another form called lactate. So when we do research on muscular activity, we measure lactate levels, not lactic acid in the blood. And that's what gets shuttled from the muscles into the bloodstream. It's lactate. And that goes to back to the liver. And the liver is able to reverse this process of glucose, pyruvate, lactate, and it's able to reverse that process, go lactate, pyruvate, back to glucose, and then it goes back into your system as blood sugar. Okay. Not a ton of it, but there's enough to where it's not fully wasted. So in the presence of no oxygen, you get this lactate, which is then removed for further processing. So the system of ATP production affords an additional 1 to 2 minutes of muscular activity. Does that make sense to you guys? So the whole point here is that when we look at these, and this is what we'll be talking about next week, are those aerobic pathways. But the point here is that when we look at the initiation of an exercise, and that's why as trainers, we don't need to go into biochemistry to any great extent, right? Because if you, and I know you do it, I know you all do it, you go onto YouTube and you're like, muscular activity, right? You go down a rabbit trail of biochemistry, and there's some really, really smart guys out there, ladies and gentlemen, that are really smart, very well educated, and they will take you for hours into an explanation of these different systems, and they are pretty amazing. For a personal trainer, kind of like an electrician, do you really need to know all that stuff when you're sitting there and putting some wires together, right? To put into a plate and put, no, you got to get the job done. So you need to know enough to understand the process. And that's what we're doing here. So you know enough that the human muscular system, and that's why we talk about fiber types. Remember we talked about muscle fiber types? Type 1, type 2A, and type 2X muscle fibers. That's where a lot of this comes into play. Okay, so the ATP-PC system is the primary system that essentially begins the process of any muscular activity. So when we're doing squats with people, dumbbell curls, lateral raises, whatever it is, and we're putting stress on muscles, it's a good idea to understand that right from the beginning, right from the get-go, we are activating these different systems to ensure that there's enough ATP to provide energy for the muscles to contract. Again, it just so happens that that first system doesn't do much for you, first 5, 6 seconds, and then phosphocreatine jumps in, gives us that extra time up until about 15 seconds. Then your body shifts into the second sort of primary anaerobic pathway known as what? Anaerobic glycolysis. Anaerobic glycolysis is a process where glucose, this is where the concept of sugar is energy. Sugar is energy. Yes, it is used as energy. You guys do know that your body does not need external sources of sugar in the human diet. You know that, right? You don't need to eat carbohydrates for survival. Your body is very well capable of producing as much glucose as it needs internally, inside your body. Your body can generate and create, and it does on a regular basis, which means that if you never ate another carbohydrate in your diet starting today, you'd be just fine. You would survive. Be no issues. You might not like it, but the point is that there's no essential carbohydrate. And we know this because of understanding these systems that we're talking about. So your body will use the glucose anaerobically to generate ATP, and your muscles can work and do the things that they need to do. Does that make sense to everybody? And again, next week, what we'll do is we'll talk about the aerobic system. So who's got questions? Who's got questions? Miss Ainsley, go ahead.
Um, you were saying, I felt a little confused. You were saying glucose goes to lactate and then pyruvate, or is it
No, that goes glucose gets converted into pyruvate
and then lactate?
and then
Or
lactate, because
yeah.
pyruvate is the is the molecule that will provide the ATP itself.
Oh,
But
yes.
again,
Okay.
we don't want to go into the, I'm not going to go into the biochemistry on this because this is what confuses people. There's a lot of biochemistry in this. A lot of biochemistry. Remember, you've got enzymes breaking down the glucose into two constituent parts, and then there's more enzymes that are working on those molecules, and ultimately enzymes that are pushing and converting the pyruvate ultimately into ATP. Okay,
Uh-huh.
does that make sense? So pyruvate is the end product that gets converted ultimately as a then the byproduct called lactate. So
Okay.
ATP is produced. You don't get much of it, but there's some, and then you get this byproduct. It's sort of like you pay a price for speed.
Mm,
Metabolically, the body pays a price for creating quickly ATP for muscular contractions. That makes sense? And the
yeah.
heavy price you pay is that you got to take some glucose, but you only get a little bit of ATP and a whole lot of waste product. But you got it
Mm,
fast. And
mhm.
that's what your body was looking for. And so that's why that's an important system. When we talk about the aerobic system, you'll see it's the exact opposite. Because it's produced slowly, you get a lot of ATP with essentially no waste product.
Okay.
Really very interesting. Rosemary, go ahead. Go ahead and unmute. Go ahead and unmute.
Um, so basically, you're saying that the ATP automatically your body has very little, and is it just kind of like you said to get you started?
It's just sitting in there. It's
It
it's
just
almost I like to use the word a priming. You know how you have to prime like your engine or something like you got to put a little gasoline. Again, I'm using an old, very old, well, I don't think it's old, but a carburetor. Sometimes in carburetors, if they wouldn't start, you'd spray a little WD-40 into it, or you can prime it with a little bit of gasoline, depending on the engine. And that would get it started because you needed something to actually start the starter right in the engine, and that's what a little bit of gasoline would do. And like the fuel, when we had fuel injectors, once fuel injectors came into vogue, they already had a little bit of fuel in the line. That's why you have a fuel pump. Why do you have a fuel
so
pump? Because it's got to apply pressure to get in there. Well, that's what ATP in there is already doing. It's acting like the base fuel pump in a car. It's pushing, so to speak, the system. It's starting the system forward because it's already there.
once it's it's you use it. Then that's what you said when you're lifting when you're lifting like the weights, then it starts up from the
As
lifting
soon
of
as
the
as
weights.
soon as you literally started to use a muscle, that
Okay.
energy that it needs to go through twitching and muscular contractions is supplied immediately by the ATP that's already in it. So it's already got a primer. It's already got a primer. And so when you're doing weightlifting activities where you're requiring larger amounts of ATP, particularly in the type 2 muscle fibers, because that's generally where you're going to see this usage anaerobically, um, because it needs a lot more ATP, it will run through that ATP-PC system fairly quickly. Let me give you another analogy. Have you guys ever watched Olympic sprinters?
Mhm.
Yeah, they put out a tremendous amount of energy, don't they? And what are the top times for top Olympic males? And by the way, even female sprinters, they're under 10 seconds. So they're running from 0 to 1,000 in 10 seconds or less. You got it? What energy systems are their muscles using? Where are those muscles in the glutes and the hamstrings and the quads and the calves and the lower back? Where are they getting that ATP? Where are those muscles generating that ATP from? That ATP PC system. They, these guys, these folks that are at those levels, same thing with weightlifters, like an Olympic weightlifter. They start and they take that weight and they go whoosh, boom. How long does it take to do a snatch or a clean and jerk? Less than 10 seconds. Less than 12 seconds. So those activities are demanding a huge amount of ATP, especially like an Olympic lifter, in a very short period of time. Well, the anaerobic glycolytic system, it takes a little bit of time to get going. And then the aerobic systems take even longer to get going. So your body has to have this system, the ATP-PC system, it's already there. We got you covered. We got you covered. And that gives enough time for the body's anaerobic glycolytic system to kick in. Does that make sense? So look, anytime we explain things like this, we have to accept the fact that we're trying to take something that is extremely complicated and make it understandable and something that you can use and utilize and understand. So that's why it's just easy to think about initial system up to 15 seconds, and then 15 seconds up to about 2 minutes of energy. And then after 2 minutes, your body's going to need another way to produce ATP. So this continuous activity that you're doing, you've got to have ATP all the time, and your body's got to, don't worry, your body's got to figure it out. So does that make sense?
Yes.
Jamisha, did you have a question? Does it make sense though?
Specifically, this was like my hardest, this was like the hardest
Part to
section for
understand,
me.
right? Yeah.
Yeah.
Yeah. Yeah. Conceptually, depending on how deep you want to go into it, but functionally, it can be a little challenging. But again, just kind of take the examples that I'm giving you and just see it from that perspective. Remember, this is a fluid metabolic process. Your body is always in anaerobic glycolysis. Your body is always using ATP PC system. Always. They are regenerating, they're recovering at different levels. And the main way your body gets its ATP PC stores back into the muscles is by doing what y'all are doing right now. Absolutely nothing. Not right now, your body is in a recovery state, whether you know it or not. Your body is not doing anything, and therefore the muscles in your body, your skeletal muscular system, is, and it's probably already completed, it's refueling the ATP PC system. So there's more than enough ATP and phosphocreatine in your muscles when in 2 hours from now, you go out there and you start running like crazy. Now your body needs those systems. But then as soon as you rest and you stop, the body recovers and regenerates regenerates and recovers your ATP PC system. Does that make sense? And yes, specific ways of training can increase to a certain extent the ATP PC stores in your muscles. So there are some very specific ways to train to do that. And the supplements, like I say, using creatine as a supplement can help a little bit with that, but that requires also pretty intense training to turn the notch, right? To move the needle a little bit more with how much ATP and PC is stored in your muscle cells. Okay, that makes sense. Sure. Was this helpful? I hope so. I hope so.
Yeah.
Well, look, guys, please make sure if you have not done so to subscribe to our YouTube channel. Let us know if you have any questions. Put them in the comment section below. Have a great rest of the weekend, and we will see y'all next week. Take care.